All right. Okay, sorry about that.
Good. Yeah. How many people you guys are first time number? Yeah. Yeah. All right. Welcome to join our meetup. So for those who are not new, yeah, welcome coming back. We really appreciate those who are coming back to join our meetup. So first, this is our time to meet up here at the Nashville Technology Council. We really thank them to offering this place for us. Yeah, you know, we usually meet at Vanderbilt. The parking is really a big issue at Vanderbilt. Yeah, difficult to find the conference room. So hope everybody like this place. We are planning to use this place for the next year. Also, just a heads up, we might change our meeting time because you see Nashville, yeah, they have a cocktail next door, yeah, every month, so we have to compete with their parking space or the meeting room.
Can we go get cocktails?
Yes. After listen to your talk. Yeah. Second, yeah, before introducing our guest speaker, I want to thank our sponsor, axialHealthcare. Yeah, they sponsor us from early this year. So Shanna Krumwid is our Axial Chief People Officer. So now I would like her to introduce Axial and talk about if there are any opening positions in Axial Healthcare.
My name is Shanna, and I'm on the team at Axial. I run HR for the company, so I'm the Chief People Officer. And thrilled to be here. I know I have spoken to some of you before after you attended these events and become really interested in careers of Axial, and Alex is a good example of a successful hire. But shamelessly, that is exactly why I am here tonight. Since the topic was career development, we thought it was okay to talk about what we have to offer at Axial. And so really, I would just encourage you to keep us in mind, right, as you think about potential employment opportunities. We are in the Gulch, we're in condensation. We've got about 75 employees today, and we're growing really quickly. In all areas, but specific to you, within science and analytics, in our R&D team, and also a team that we have called healthcare analytics, and then also in the engineering and technology group. So please come by and say hello, hang out after the meeting, stack of cards, or you can also find me on our website. Because all of our jobs are there. Our jobs are also in LinkedIn. So don't think it's hard to find us if you would like to express interest and start a conversation. But please know that we would love to hear. Thank you.
Yeah, now let me introduce our guest speaker, Dr. Lindsey Morris.
Thank you.
Yeah, Dr. Morris is the director of data science and analytics at Axial. She got her bachelor degree from University of Tennessee at Knoxville and her Ph.D. at Vanderbilt, both in chemical engineering. Yeah, she served as the president of the Postdoctoral Association at Vanderbilt and competed in the TechVenture challenge hosted by Life Science Tennessee. Dr. Morris and her team at Axial provide data-driven support tools to physicians and other healthcare providers to better manage their patients who are in pain and consume opioids. The topic today is part of our career development track. So please help me welcome Dr. Lindsey Morris.
Thank you, Chad. That was very dramatic. All right, I'm going to turn this a little bit. Let's see. Get situated. Technology. All right, here we go. All right. So just by show of hands, how many of you are full-time students? Okay, 40-ish%. How many of you like work in healthcare analytics? Probably about the balance. Okay, so great. I think my talk today is probably geared a little bit maybe more towards students, but anyone kind of wanting to enter into the field of data science, and I think generally just really some basic career advice. So as Chad mentioned, I work at Axial, and I'm not really going to spend any time talking about what we do at Axial. I've talked to a few of you here tonight, but if you have any questions about Axial at the end of the talk, I'm happy to answer those. But basically, what we're going to discuss today is this agenda. So what does a data scientist really do, particularly through the lens of Axial Healthcare? What happens at a healthcare startup? Many of you might be interested in working in a small business space, so we're going to talk about that. And then we're going to go into some career advice. So I'm calling this Lindsey's no nonsense, no BS, real deal career tips. The reason I'm doing that is I thought about, I'm sure that a lot of you have been to career talks. Tell me what some of the more common career advice that you guys hear a lot. So I'll get started. One tip I hear a lot is don't have any mistakes on your resume. Any others? Come on, guys.
Networking.
Okay, network. All right, good one. Anybody else? Career tips, like what are common career tips you hear?
Join a meetup.
Join a meetup, okay? All right, that's good. Anything else?
Personal projects.
Personal
Personal projects.
projects, okay, that's pretty good. Just kidding. That was great. Okay, I'll do another one. Follow up after the interview. Okay, we hear that a lot, right?
Thank you notes after,
What's that?
write a thank you note or email after the interview.
Write a thank you note or email, absolutely. Anything else commonly you guys hear just for interviewing, get a job, whatever? Okay, well, I'll end it there. There's definitely some really kind of common tips we often hear. I really didn't want to talk to you guys about those tonight because we hear them so often. So I'm going to give you some of my kind of personal advice on what I think is needed in order to be successful in the workplace. It's probably going to be stuff that you don't really hear very often, but I think is really important. And then lastly, how do postdocs and graduate students break into this field? I think since we also have some people in the healthcare analytics space here tonight, we can talk about that too. Okay, so data scientists, here's what Google says. You Google data scientists. I'll read a little bit of this. Data science, also known as data-driven science, is an interdisciplinary field about scientific methods, processes, and systems to extract knowledge or insights from data in various forms, either structured or unstructured. Similar to data mining. Sounds extremely sexy, like something I definitely want to do. Data science is a concept to unify statistics, data analysis, and their related methods in order to understand and analyze actual phenomena within the data. A lot of truth to that. Again, sounds extremely sexy, definitely want to do that. This is from all sources of knowledge, Wikipedia. And then I often see on the internet this sort of Venn diagram of what encompasses data science. And I think probably a lot of you have seen this previously. So data science as a discipline encompasses really three main arenas. So computer science and IT skills, math and statistics, and then domain and business knowledge. And I think that's a lot of the reason I think Ph.D. trained people are successful data scientists, because we typically have some experience in all three of these areas. And I see this conceptually in a lot of places, so I think it's pretty true to form, and I believe this at Axial as well. Okay, so data scientist reality. What do we really do on a day-to-day basis? The first one, and I can't stress this enough, data wrangling. This is 80 to 95% of our time is data wrangling. So when you are a student, whether you're in computer science or some sort of science, a lot of times, especially in a class setting, data is given to you very nice and neat. Like they want you to do multivariate regression, or they want you to do a very exciting clustering algorithm. And the data is just handed to you, and it's very nice, and it's very angelic. In practice, this is just not true. Like, data does not come to us with the measurements all nice and neat and packaged up for us. So a good example of something that we might have to do is measure whether a person has opioid dependence. And at Axial, we analyze medical claims and pharmacy claims. So how do you know if a person is dependent on opioids? There's not a data field that says opioid dependence, Boolean true or false, right? So we have to understand the data and understand and define what opioid dependence means in that data, and that can actually take a really long time. And when you start kind of building all those features, then you start doing your data wrangling activities for 95% of your time. We also spend a lot of time understanding how to interact with the data. So we use R and Python. Those are kind of the languages du jour of data science. We'll talk about that in a minute. So overcoming kind of technical debt, just how do we interact with the data? Do we need the data in a data frame? How do we get it into a format that's usable to do our data science? Also looking for new sources of data and just understanding the data we have, finding inconsistencies in the data that might affect our analyses and therefore affect the conclusions that we make from any analyses. Also making new data measurements. We do a lot of that, and that's part of the data wrangling. We also provide documentation of the measurements to the business. This is very important. It's something that I didn't appreciate in the beginning, but it's very important to document your work. It's very akin to keeping a laboratory notebook. So basically the documentation that we provide is kind of like a scientist's laboratory notebook. We also deliver a lot of summary statistics and visualizations to the business. This has a really high value to our clients. I think a lot of people think of data science as, really solving very complex problems, and there's a lot of truth to that. But I think the reality that I didn't appreciate early on is that just delivering a mean or a median or a histogram to our clients can actually be super valuable. And I think from a scientific standpoint, you really can't discount just looking at your data, just plotting the data, just making a histogram, just looking at a scatter plot. That's really simplistic, but it really helps you understand the data very well. And I think it's really a critical component to leading to those more complex analyses. We also search a lot of literature. We keep a library of literature at Axial, and we do a lot of ideation, so idea generating that would feed into our products, and we support ad hoc client and business needs. So technology tools, I won't spend a lot of time on this. I'm sure you guys are familiar with most of these. These are just some Google images I snapped from the web, but these are some of the technology tools that we have at Axial and that we use. I would say generally as a data scientist, what you need to learn in terms of your technology stack are kind of three concepts: storage of data, querying of data, and processing and analyses. This is usually accomplished by what I would consider a data science programming trifecta. So you pretty much have to know SQL, and then either Python or R or both. It's pretty rare that I've seen data scientists use any other tool. These are just very common out in the wild. I think if you work in an academic setting, a lot of people use MATLAB. I was initially trained on MATLAB. It's pretty similar, I think, to Python. The syntax is pretty similar. Also, understanding bash and command line tools is necessary, and also understanding conceptually about databases and data warehousing, I think, is really necessary for data science. Okay, so I'm going to give a little story. I've talked to a few of you how I came to Axial Healthcare, and I think this will kind of lead us into some tips. So I'm originally from Knoxville. I got my bachelor's degree in chemical engineering. I was young and not a lot of thought went into that. My mom is a high school math teacher and she told me not to be a teacher. So I was like, well, I like math and I kind of like chemistry, so I guess I'll be a chemie major. That's kind of the thought process that went into that. So I actually decided to matriculate into a Ph.D. program after my bachelor's degree. So I started at Vanderbilt in August of 2000. Actually graduated from UT 1 week and moved to Nashville like 2 days later. It was pretty crazy. So I actually spent some time after getting my PhD sort of not really understanding my career very well. I took a series of jobs. I was a research assistant for a couple of years. I actually worked as a process engineer at a paper mill in Arkansas for 2 years. Because I thought I would, try to maybe be a professional engineer. I didn't really like it. I ended up quitting the job actually and returning to academic research. So I worked at the University of Arkansas for Medical Sciences as a lab manager for 3 years. I was actually planning to move back to Nashville, but I had met the man who I would marry, so I decided to stay for him for a while. So when we got married, we moved back to Nashville and actually took a postdoc back at Vanderbilt, and I was a postdoc for 4 years, so it was pretty circuitous. But during the time that I was a postdoc, I think I learned a lot about career development and how to cultivate my career, things that I just didn't appreciate early on, so it was actually a really good experience. During the time I was a postdoc, I started getting heavily involved in professional organizations. I ran for office. I was president of the Postdoctoral Association. I started organizing seminars. I actually ended up participating in the TechVenture Challenge hosted by Life Tennessee. Raise your hand if you know what the TechVenture Challenge is. A couple of you. So it's actually a small business entrepreneur student competition where you're given a technology and you have to develop plans to market the business to venture capitalists. And it was definitely unexpected that I liked it, but I found it pretty exhilarating. I was actually the pitch person for my company, so standing up in front of 5 really high-powered attorneys in the Nashville area, I don't know, it kind of just resonated with me. So I actually, around that time, Elizabeth Ann Springer, our chief science officer, came to give a career talk at Vanderbilt. So I met her, and I asked her if I could come shadow at Axial. And she said, sure, of course. So Axial was like maybe 4 or 5 people at the time. They were at the Entrepreneur Center. And so I started coming there like half a day a week, 1 day a week sometimes. They actually asked me to make a graph in Python. I had no idea what I was doing. But I made the ugliest, most horrible blue bar graph, like Times New Roman font, because I couldn't figure out in Matplotlib how to change the font. And anyway, they ended up loving it. So I said, okay, that's cool. So a couple months after that, Axial got their first round of venture capital funding. And I remember approaching Elizabeth in the parking lot. I was so nervous. I don't know why, but I said, I don't want to be presumptuous, but if you're going to hire, I would be interested in working here full time. And she was like, all right. So I didn't know what would come of it, but actually a couple weeks later, they offered me a full-time job. So I've been with Axial since that time. So that's kind of my career story and will lead me into some career tips. So what's it like to be a data scientist at a healthcare startup? It's kind of crazy. I just wrote a few things about my experience at a startup company. So very fast-paced, quick turnaround times. A lot of times early on, you're involved in data exchange meetings and client meetings, which is probably not traditional data science, but when there's 10 people, you do what you need to do, right? A lot of times early on, there's no clear delineation between development and deployment. So a lot of times you're developing stuff and it's going directly to the client, and then it gets integrated into the product. So there's not really a clear process in the beginning. I will say that I think early on, I worked essentially as a healthcare analyst. So I did a lot of client reporting, making a lot of trend lines, a lot of different bar graphs, a lot of summary statistics. Which sounds boring, but it was so fast-paced and it was kind of so exhilarating. We're trying to get clients that I actually really loved it. And I think, the next bullet point I had, so what's the difference between a healthcare analyst and a data scientist? I think a lot of the tool sets sometimes can be similar, and I get this question sometimes. So I think what differentiates a data scientist a lot of times is the ability to do scientific testing and experimentation on data sets. So if you're trained in hypothesis testing, design of experiments, drawing appropriate conclusions from those experiments, and being able to effectively, concisely communicate those results in an unambiguous way, I believe is what differentiates a data scientist from more of the healthcare analyst realm. So you get a lot of on-the-job training, experience. You're spending time trying to woo clients. Maybe we're kind of still in that phase, but you're really just trying to get revenue positive and get clients to contract with you in the beginning. You're dealing with short timelines, ambiguous requests, and you're providing insights on the data. So that's a lot of what you're doing in the beginning, and you're also integrating with Agile workflow. Do you guys all use Agile? Raise your hand if you do. A few, right? Yes, Chad. So yeah, that's a concept that I wasn't familiar with, and honestly, it's been kind of difficult. I think the development time for a scientist is different than I think for a development of a piece of software. It's usually longer, it's usually more ambiguous, you're not really sure exactly what the results are going to be. So trying to integrate that and understand how to integrate with other teams, I think has been a challenge, but I think it's we're definitely starting to conquer that at Axial. I just gave this slide as a little example of kind of the data artifacts that, especially early on, that I would deliver to the business. So bar graphs depicting pain-related medical expenditures for patients in pain with and without opioids. Also graphing some sort of trend lines for the risk scoring models that we have at Axial, and illustrating that the more risk you have for an opioid overdose, the more your spend is. So these are the kinds of things that, as a data scientist, that I would deliver directly to clients. We also deliver, as I mentioned earlier, opioid use disorder examples. So we deliver complex measurements. Right now at Axial, we've done decision trees, multivariate regression, and targeted outreach methodologies. So those are the more traditional, what Google says data science really is, kind of things that this team has done so far. I actually think I'm going to skip this in the interest of time. We can come back to it. So we're going to go into Lindsey's career tips. Lindsey's not so popular, real deal career tips. So one of the biggest tips I have is that there's really no silver bullet. I think, particularly as a trained scientist, I think what was difficult for me early on is that I wanted to do something and expect a specific outcome. And I think when you're managing your career, it's not that simple. So you have to kind of be comfortable with a little bit of ambiguity and really kind of not knowing what's going to happen next, but there's definitely targeted things that you can do to get to where you want to be. Probably my biggest tip is get involved. One of the biggest things I did at Vanderbilt, and yes, I do believe that probably my science as a postdoc suffered a little bit because of it, is that I did a lot of extracurricular stuff to try to cultivate my career during that 4 years. So I volunteered to organize events, seminars. If you do it over and over and over again, then people will get to know you. They will begin to know what you're like as a person. They will know that you're good to work with. They will be able to introduce you to others. So you just really start to develop those relationships. I served on symposium meetings and organizing panels for local and national meetings. I ran for professional organization leadership roles. I asked to shadow. So I did that at Axial. It was very successful, I think. Another thing I didn't put on here is I did a lot of informational interviewing. That's another career tip that I hear a lot. I think a lot of people, especially students, or maybe I can only speak for myself, I'm going to do all these informational interviews and I'm going to talk to people and they're going to love me over the phone and be like, hey, we have an opening. And I'm going to be like, hey, that's awesome. Like, I'm looking for a job. That never happened. So I think organizational interviews are very good. I think if you don't know what you want to do in life, they can be extremely helpful. I spent a long time thinking that I wanted to be a process engineer in big pharma. I did my postdoc in drug discovery, and that's just kind of where I thought I was headed. But after talking to scientists at pharmaceutical companies like Pfizer, Merck, stuff like that, I was like, yeah, they seem really miserable. I don't know if I really want to do that. Also, offer your help, experience, and services. You have to make your interactions mutually beneficial, and I think that's why I was successful at Axial, is that I was actually doing something for them that was of value to them. It was actually a value to me as well, even though it's interesting. I never thought that I would get hired full-time by Axial. But I was getting something for it because I was really seeing what a small business was really looking like, what happens there. I was learning Python at the time, so it was a great way for me to sort of dive right in and make my horrible blue bar graph, stuff like that. So I think that's an important point, that you can't really go into sort of entering into these interactions like I need. It's better to enter into them with the approach that I have something that this person might find beneficial, whether it's financially beneficial or just beneficial to their career somehow. And I think that really helps you cultivate your professional interactions. Make sure your LinkedIn profile is up to date. I interview actually a lot of people for me anyway. It's something I've never really done before, but my position at Axial right now has caused me to interview tons of people. And I always look and see if they have a LinkedIn profile. I do it every time. I Google their name. I'm sure probably Shannon does too. And if your LinkedIn profile is like riddled with errors, or it's like no picture and empty, then that's, I'm going to not really have a great opinion, right? That tells me that maybe you're not detail oriented, and you're not putting yourself out there, putting your best face forward. You're not, it doesn't really take that much time to put, a good LinkedIn profile up there. So if I have nothing to go on, I only have your resume and what your empty LinkedIn profile. That's pretty difficult. My recommendation for careers also is to have 2 resumes. So for those of you in the sciences who are master's or PhD programs, have a lengthy CV ready, but also have a shorter 1 to 2 pager. This is my personal opinion, but when I look at resumes, I really want to hit the highlights. Even though I don't read a lot of resumes, I don't really enjoy it that much. So I'm probably just going to skim over. I'm kind of going to look at what you've been doing. Don't put like 50 bullet points of every single activity and project that you worked on in your life, because I need the too long to read version. So have always those 2 different resumes ready. And also reach out to staffing firms. I think this is harder if you're just entering the job market, because I think it's difficult initially. I think a lot of search firms don't have really openings or clients who want like fresh out of school grads. But certainly if you currently have a job and you're looking to move into data science or another type of career, I think search firms can really work for you. All right, these are more tips geared toward sort of how you interact at your job, or how you interact maybe at a meetup. Practice emotional intelligence. So monitor others' emotions and be self-aware. I can't tell you how many times in practice that it's not that we're looking for a specific skill set. It's not that you maybe didn't write your where clause in your SQL statement correct. It's more, do you fit in with the team? And if you don't, don't have that emotional intelligence in that component, then it's just not going to work well. Attend work social events. I think this is important. A lot of times business networking and mingling is very social. A lot of times, a lot of the interviewer tips I've seen online is like, can you imagine yourself sitting down with this person and kind of hanging out and have a beer? If you can, it's probably going to be a good fit for the role. Also work well with others, know when to push back, when not to push back. A lot of mistakes that I've seen, especially as a PhD student and in the workplace, if you don't get along with people and you're always pushing, then it really sort of doesn't lubricate those professional relationships that you need to do. Stay positive and upbeat even when you're not. And then when you don't agree with others, be able to kind of gently persuade them, because a lot of times what I see is that you have to look at things through the other person's lens a lot of times. And it might not be very apparent that their needs might be different than yours, and they might be in direct conflict. So just kind of be aware of that. listen, collaborate, and understand other people's experiences. So, I can't stress enough that sort of the social interaction component is very important in business, and I think it could really make or break you in your job. I think it can make or break you in the interview process. Okay, so these are more interviewing tips. I've had people just show up at Axial, like unannounced. Don't do that. Even if I had time to meet with you, the answer will be no. Yeah, don't do that. Not that I think you would, but I've seen it happen, so if I put it in my real ability tips. Be on time for interviews. I've had people show up for interviews like 30 minutes early. I have nowhere to put you. Conference space is at a premium. I know this sounds weird, but if you're early, I get it. Nashville traffic, all horrible. So if you're 30 minutes early, hang out downstairs on like Facebook for 30 minutes or something, and then come up. Just like don't be too early. Like 5 minutes early, that's good. Know your resume. I've had people. I can't tell you how many times this happens. I look at people's resumes and be interested in a bullet point on their resume, and like they can't remember what they did for that project or can't remember the project. Like don't do that. I can't stress this enough. Be able to concisely and succinctly communicate what you've done. A lot of times in the interview process, especially if I don't know the person, what I'm looking for is them to be able to explain to me projects that they've worked on very clearly, with the understanding that I might not be a subject matter expert in that area. Okay, and this takes practice. It's not something you can just show up and do. So you really have to practice communicating what you've done to others. I can't tell you how to do that. I mean, practice with your mom, dad, significant other or something. Also be able to explain how your work has added value to the project. This is something that we ask very often at Axial. We want to understand you didn't work on this and not understand business objectives or business needs. From an academic perspective, make sure that you can communicate that this work was important because there was a gap in knowledge in this area and we really needed to contribute to scientific knowledge. Also, know where you see yourself in 3 to 5 years. I think early on for me personally, this was difficult because I think I really didn't know where I wanted to be, and that's hard. But fake it till you make it, I guess. So at least have a good understanding, or at least some sort of position about where you're going to see yourself in a 3 to 5 year time period. Never, ever, ever, ever demonstrate anything negative in a job interview. This will be an immediate no, and I've seen it happen. If you badmouth your current position or you're just overall kind of a negative attitude, I think it goes back to my previous slide, sort of working well with others. A deal breaker, so just don't do it. Even if you're horribly unhappy and you're going home to drink whiskey later that evening, just don't be negative. I think, we're kind of here to talk about data science, so I gave a couple of tips about if you're not currently a data scientist, how do you get into the role? This might be a lot of your questions tonight. So this is a personal opinion, but online certifications like through Coursera and stuff like that don't really resonate very well with me. I'm not saying they're bad, but if that's all you have going for you and you really don't have anything else, it's not really going to get your foot in the door, at least with me. And I think that's important to say because some of these are my opinion as a data scientist, as a manager, as an interviewer, and I think there's a lot of varied opinions, so I do think you should talk to others. But I don't really put a lot of weight in sort of online certifications like through Coursera. I think it's good to take Coursera classes. That's how I learned Python. It's definitely not bad. But if I don't know, if I've been like working at a golf course and I took an online Coursera class in data science and then I want to be a data scientist, I don't know, it just doesn't really connect with me. I think things like data fellows, Insight Data Fellows is an exception. I actually don't know much about Data Insight Fellows. I put it up here because I think it's kind of up and coming and it seems to be pretty popular and competitive. It's actually a program that you're accepted into, and I think you're pretty much guaranteed that data science job afterwards. you can look it up online if you want to know more about it. I think getting familiar with the tools of the trade. So get an AWS account and do stuff with it. You know, make a website or something. Take Python or SQL courses online. I put a few up here: Kaggle, Exorcism, Coursera, Code Academy, Pluralsight. Reading these O'Reilly books for learning Python. I mean, this is geared for Python because I had a discussion with somebody earlier. I mostly use Python. R is definitely out there, but yes, R as well. Know how to use Stack Overflow. I use it all the time to sort of learn programming. Have a GitHub account with your code. That can resonate with me. People who have told me that they have GitHub accounts with some code they've written, I've actually gone and looked at it. So I think that can really help you. Big point is to demonstrate and cultivate your ability to ask the appropriate questions, design an experiment, and draw appropriate conclusions. A lot of times this really is what we're looking for. I want to know that you can understand contextually what the important questions are and research them. Know some statistics beyond the t-test. I think my opinion right now is that statisticians make great data scientists because a lot of stuff we do is very statistics based. I even feel like I could beef up my skills in this area. I'm not a statistician by trade. I had stats classes over the time that I was a graduate student and a postdoc, and I kind of crush on the area. I kind of think I'm a closet statistician a little bit, but I think just so much of what we do is statistics based, so I think it can be really important. And if you don't know a lot of stats, I think you're going to struggle in this area. Also, volunteer your time and expertise. You know, that's how I got into Axial. I volunteered time. It wasn't paid. It was completely pro bono, but it really did a lot to cultivate those professional relationships. And I think even if I had not been hired at Axial, I was working directly with people in sort of a data science role that could definitely help me meet other people in this arena, and you know, that's really invaluable. Bottom line, work on a project that helps other people, and that's the thing. You've got to develop these relationships and have it be mutually beneficial in order to take that next step in your career. And that's maybe a personal opinion, but I certainly think it's a concept that's out there, and it's worked for me, and I really believe it. Okay, so I think we're just about out of time probably, but I think that's all I had. So I'm happy to have some open discussion. Any questions that you might have for me about data science in general or careers or anything else, I'm happy to talk about.
Yes. Go back, talk about the.
Oh, Chad loves the pyramid. Yeah. Sorry. I skipped over this a little bit. You know, this is more data science-y. Raise your hand if you don't think that you really know what data scientists really do. Nobody? Okay, I'm done. No, I'm just not. I've been thinking about this a lot. This is something, you know, Axial's at a point right now where we're coming up with what our research goals are going to be for 2018. And I've thought a lot about sort of what we do at Axial, how research and development can be leveraged really at this company. A lot of times, and I think this is common in the healthcare IT space, companies get started with a lot of descriptive analytics, and that can really have a lot of value for clients. You know, just measuring the number of patients who have pain. You know, companies don't have resources to do that, and I mean, it can get complex, but you know, just kind of simple measurements like that can really have a lot of value, especially early on. And I think that, you know, Axial has really started having sort of a formalized R&D team in the past year, and I've been thinking a lot about, you know, where we need to move the company, where we need to move research, where we need to move products. And this has kind of been talked about, you know, lightly over the years, but I think this concept is really going to drive where we're going in the next year. So in terms of the research that we do, the models that we build, I think we want to move kind of stepwise from descriptive analytics into diagnostic. So a thing happened, we measured it, we know it. why did it happen? Can we tell why a person was in chronic pain? Can we tell why a person escalated to opioid dependence? Then predictive, what will happen next? Can we tell if a person, and predict and calculate an odds ratio if that person is going to escalate into opioid dependence, or whatever the outcome may be. And then prescriptive, how do we keep it from happening? Do we send that person to mindfulness training? Do we have evidence in the data that that's going to be the case? So that's sort of, to me, that's data science. That's a lot of what we do and how we move. So we talked about this today. Chad got excited about it. Anyway, yes. We had a question back here first, Wayne, sorry. Is she back here? Yeah.
No, my question was how about SAS programming language?
Yeah, we hate SAS. No, I'm just kidding.
Can you repeat the question so
Oh,
people hear it?
Yeah, he said, what about SAS programming language? It's funny, I was talking to some of the data science members the other day, and so there's kind of a joke within our team that everyone's using R except me. I'm using Python. And we're like, oh, well, you know, Lindsey's pretty lame, she's still in Python. And then we're like, well, can we talk about the things we mutually hate, which is Microsoft and SAS? Anyway, sorry, I guess that was funny to me. I don't know SAS. I think my experience is that it is used very widely in larger companies that are willing to pay lots of money for software licenses. Axial as a startup, it's not that we can't afford it necessarily, but the open source tools are in Python, kind of have everything that we need, so we don't really have a business case to go there. Anyone in the back?
You might have already answered this question, but what would you say the state of data science and healthcare analytics is in Nashville? Is it booming? Do you see it?
I think it's booming. I see a lot of job openings. Axial currently has openings. I think it's up and coming, and I think it's only going to get hotter, in my opinion. Because if you think about it, I think what drives it is just technology. Like, companies are collecting more and more data. You think about cell phone usage and iPad usage, computer usage, and no one knows what to do with it. And there's a lot of insights to be gained. So I think it's a field that's only going to grow. I think at Nashville being a huge healthcare hub, there's tons of opportunity. So I see it as pretty hot. Yes.
So you just explained what data science is, but one of the things that I get the feeling about is in the job market out there that the term becomes very vague. On the employer side, you want to say, hey, we hired data scientists because it's a cool thing right now.
Yeah.
And on the employee side, you want to be a data scientist even though you just know SQL or you're just, there's a lot of big breadth of things there.
Yeah.
Do you feel like that's the case? And what is the real data scientist?
So I think data science as a discipline is still pretty ill-defined. I think there's a lot of opinions out there. I have my own opinion, which may or may not matter to most. I just still feel like it's so new that it really hasn't grown into itself. And I think people who are in the discipline can sort of push that agenda and push data science as a discipline to what we think it needs to be, sort of thought leaders think it needs to be. I think it runs the gamut. It's kind of interesting. I actually spent some time before this meetup searching for data science jobs on Indeed. It's pretty variable what employers want for the title data scientist. And it's variable educational level wise. It's variable in terms of like what they're doing. But they all list, we want machine learning algorithms. Everybody says that. I kind of begun to really hate that term. It's because machine learning is a tool to answer a question, right? And I think that oftentimes you have questions, let your scientists use their expertise and make the decision whether a machine learning algorithm is the appropriate tool to answer that question, and oftentimes it's not. So I think it's sexy to say that, but I think in reality and in practice, that's not oftentimes sort of more complex things for what is needed. As a field, I think data science to me is just that. It's being able to contextually be presented with a problem from the business, or in the academic sense from the field, and be able to say, all right, I've got data, I need to design an experiment in order to answer that question. And I need to use the appropriate tool to answer the question and look at the results and be able to interpret those results and either design another experiment based on that result or deliver that result to the business. To me, that's data science. And that's not easy. That's not an easy thing to do a lot of times. People spend years cultivating their careers just doing that task. I don't know if that answers your question. I kind of waxed poetic there for a minute. Yes.
Do you think data science has grown from the business, like a higher level of business intelligence analysts who have been charged with designing the dashboards for the business and addressing the requirements the business wants?
Yeah.
But then the scientists maybe take it to the next level and do the experimentation, like A/B testing and all the different statistics with the data, and maybe answer some new questions that involve a bunch of different data sources. And it's that wrangling that they might they might do testing on massive amounts of data versus pull all the data in and analyze all the data.
Yeah, I think that's accurate. I mean, I would hesitate to say that sort of an analyst is down here and a data scientist is up here, because to me they're two different functions, and so I don't want to disparage a healthcare analyst role because it's such an important role. I think they're different in a lot of ways. A healthcare analyst, I guess I can only speak for Axial, but I'm sure there's probably maybe more people in the room who day basis. But it is more providing sort of outcomes reporting to the client, sort of helping them understand trends each month, helping them sort of understand what's being delivered to them. That's such an important role, and there's some data science-y concepts in that, because you've got to be able to communicate a story to them, and that's oftentimes what they do, and that's what a data scientist would do as well, communicate story of the results. It's just kind of a different function. I mean, there's some similarities, and I think that muddies the waters a little bit, but I think you're correct that a data scientist is charged with giving insights using the data, but maybe different flavor of insights than a healthcare analyst would. It's just maybe my take.
Have you ever used the tool Alteryx?
No.
Okay, check it out.
You're grinning, so
It's a
we'll
great
talk
tool.
about it later.
Yeah.
Yes.
So I think commonly, for most models, do we handle bigger data, like you mentioned, maybe bigger than 1 terabyte?
Yeah, I actually kind of maybe skipped over that. I had something about that. Yeah, storage, query, and processing analysis is a big data set. So in prepping for this talk, okay, so we hear the term big data, and I've often had the question, well, how big is big? I don't know what big really means. It's pretty ambiguous. I've seen a couple of blogs. I don't know how accurate they are, but kind of the flavor from my Google sleuthing was that big data is greater than a terabyte. I think the biggest data we have, I don't know if that's proprietary. Let's say it. It's greater than a terabyte.
So you deal with development of it. Can be a small data set.
Yeah, so from a scientific perspective, we'll go back to the designing experiments. You've got data sets that actually we have claims data. Many times you don't want to analyze all that data. You want to select an experimental cohort based on your research question. And that's when the data wrangling comes in. Like you might need patients who have knee pain. well, it doesn't make sense to like get all the terabyte of data. You really just need patients who have knee pain. So you go find those patients, you mine, I guess, as it were, and then you get your experimental cohort out. So, I mean, realistically, you're not, at least in an experimental sense, you're not processing tons and tons of data, unless you're doing things like feature discovery, right? Which I don't know, in my experience, there's so many ideas and so much to do that it doesn't make sense right now for where we are to spend time doing like mining and feature discovery like that. I think if you're charged with sort of more riskier projects and unknown questions, then yeah, that makes sense. Sorry, let's go to you first. Yes.
So when you're hiring for a data science role, you are asking the question, where do you see yourself in 3 to 5 years?
Yeah.
What are you looking for?
I'm really just looking for people to have an opinion. I mean, if it's like, well, I don't know, then yeah, I mean, it just doesn't resonate well. Like, I think I don't know, some of us, I'm of a certain age maybe. My parents went to work for a place and worked there 30 plus years and retired. People don't really do that anymore for the most part. So I think people naturally right now think of their careers in like 3 to 5 year chunks. So, what I'm looking for is, do you want to stay in a technical role in the next 5 years? Do you see yourself like down and dirty in the trenches doing stuff? Or do you see yourself moving into more product development? Or do you see yourself being a manager? Or, how do you, like, when you think of yourself 5 years from now, professionally, what do you envision? So I'm definitely looking for an answer.
I think I would add to that too, Lindsay. I think it's important to not tell untruths, right? In an interview.
Sure.
But you should always convey a sincere interest in the actual job that you're interviewing, right? I feel like candidates sometimes will unintentionally leave seeds of doubt that then hiring leaders or HR people are left trying to figure out job. I think maybe they don't, right? And so you can unintentionally create a problem for yourself in that way when it doesn't sound like you are laser focused on this kind of work. Not like, don't go so far as to tell lies, right? But I do think that that's important. A genuine interest.
Yeah, I agree. Okay, yes, next.
Yeah, this is like pretty common interview, I guess, but like, is there an instance that you can kind of briefly describe where you, I guess describe the process of thinking about a problem and arriving at a solution with kind of data science mindset that you had to solve it?
Wow, that's a great question. Like, I'm on a hot seat now. I need to think of an example that's not proprietary. Yeah, I'm trying to think of an example that I can give with Axial without divulging IP information. So an example might be that, here's an example. So we might have a problem that the business comes to us with, and they're like, okay, well, our clients have a lot of people who have opioid use disorder, and they're going to seek treatment, seek pharmaceutical treatment for medication-assisted therapy, but then they're kind of falling off the wagon. Maybe they're going to the ED, or they're having high utilization, and they want to know what to do about that. So, data science team would sort of take that information and say, okay, well, we've got products, maybe we can integrate some solution into a product. Maybe we need to understand more about what is happening in these patients' lives. that they are seeking treatment, but it's not being effective, right? So then you start sort of massaging that a little bit and leading to research questions like, is there, you might do some sort of, I hate to use this word, it sounds horrible, but like patient profiling. So maybe all the patients who, first of all, you gotta find who these patients are, right? So data wrangling. So who fits this category, and let's go get their medical records, and then maybe you find out that all the patients are male. So okay, well, we know all the patients are male. Maybe they're at a certain age range. Then you kind of start asking questions. Maybe the patients are in pain. Maybe they're not. Maybe they might be illicit drug users, which we don't really know. So then you start formulating kind of research questions to sort of understand that population, and maybe sort of, it kind of moves up that triangle hierarchy that Chad loves, right? Descriptive. You describe this patient population in which the client is sort of having some trouble with. Then you move into diagnostic. Why not? You start asking questions like, why might they be on this track? Let's maybe start looking at other patients who are similar to those patients but have their opioid dependence resolved. Can we sort of make some, that might be, then you kind of start moving into more predictive. Maybe for the client, what they're asking for is something predictive. Maybe they want to predict relapse from medication-assisted therapy. Well, we need to build a model for that. We need to understand features that might predict that. We need to understand even how to measure that, because that's not easy, right? So that's kind of the thought process that would go on in the life of a data scientist, and I think what you end up doing along the way is that you deliver sort of piecemeal insights to the product. It's not like, businesses like Axial or any business can, wait 5 years throughout a PhD dissertation to deliver this like perfect, beautiful peer-reviewed model at the end. Right? It's just not like that. So you end up delivering sort of like client, just an identification of those patients that might have this problem, and then you deliver maybe some content that might help them based on some features that you've noticed in the data, or so you kind of like build the product in that way, and that's sort of what your R&D team does. They're presented with a problem and they develop a plan for the client, and then sort of it iterates. Okay. Yes.
I think your last question, really helped answer this one, so skip over it. But it sounds like there's a project and there are multiple team members who work on a single project. Is that true, or is it more like each individual data scientist has their own project, or they primarily have ownership of? And
Yeah, that's a good question. So right now at Axial, our data science team is split into being assigned to one of our 3 products. And they are working on projects underneath those 3 products. I wouldn't really say at this point that any scientist works on the same project per se. It's kind of muddy, but to note is that they have to work very closely with our product, process, and engineering team, so they're not working in isolation. It is not like a PhD or master's degree program, if that's what you're really asking. So no, it is definitely much more team-based than what you would experience in a master's degree program. Yes?
Outside of just data science, I already remember I'm a data engineer, and I kind of work often between data engineering and data science. And one of the challenges that we've been facing is how you get the data scientists to build a model, to understand what's going into it, and productionize it. Yep. And it's got a lot of tricky parts. Like, how do they know that the data on their side is doing the same data, the version, all that stuff? Sure. How do you guys do that? Is it comfortable yet?
Luckily, we have a member of the data team here. So now, and you can correct me if I'm wrong. So the model, so Axial's been growing, right? The models that we've had were really kind of in place. Really a lot of hiring that happened at Axial. So our deployment process has looked like basically just sort of transferring ownership of that code over to the engineering team. I don't think that's really ideal. I think what we're moving toward, again, you can correct me if I'm wrong, Alex, is sort of you've got development cycles on the R&D side, right? So we go through our development cycles, and all of a sudden we've got something, and we're like, okay, this is baked into some version of this product or whatever. And what would happen is we'd be paired with a member of the engineering team to sort of, we would provide documentation and requirements and data artifacts. So whatever Python R SQL code that we wrote in order to develop that model. And then we would have like written requirements and also like literally written equations of the model. So that would be handed over to engineering, and then we would work in conjunction with them to deploy it in whatever means that they see fit at that time. So it could be that they use the code, the artifacts we deliver. It could be that they recode it in another language. That's really their decision on their end. Would you agree with that? Okay, perfect.
Obviously, there is kind of like an end over the wall, but,
Yes.
but it's not completely like you're now
No,
work together to make sure
we have to.
that works.
I think you have to, because it's, I don't know how it could be deployed if we just like, said, here you go. It's not like that at all.
There's definitely a feedback loop where once we
Yeah.
professionalize it, we have an entire process where we analyze the deltas between the existing model and the new proposed model. We work very closely with the data science team, and also not just data science team, but also our analytics team, because that's going to impact reporting, which goes to our clients.
Right. Yes.
So when I think of the three pieces of the Venn diagram,
Yeah.
I always think of the domain knowledge as like the one to not think about until you've got a job. Is there anything like healthcare related that would make a candidate look more appealing? Like, oh, they've,
Yeah.
been to the hospital.
I think this might get to some points that you had. I'll be honest, when I was hired at Axial, I was not in the healthcare space. I come from a very heavily academic background where I worked on scientific projects that probably no one will ever care about for the rest of their lives. So, I mean, they took a chance on me, but to be honest, based on Lindsey's no-nonsense or little career tips, I developed a relationship with them. So I think Axial generally as a company sort of took a position, especially early on, that they were going to bring in people who maybe didn't really have a lot of healthcare knowledge, because it was kind of a strategy, right? We're not jaded, maybe. Maybe that's the wrong term, but I think there's just a fresh lens, right? Like, I have no preconceived notions of the healthcare space. So therefore, maybe I'm too dumb to know that I can't do what I'm proposing to do, but I do it anyway, right? I think from a data science perspective, I personally don't really care that much if candidates don't really have healthcare experience per se. I think from a healthcare analyst perspective, which is kind of what you guys were talking about, that's a little bit more important to have that domain knowledge, particularly in the early stages of a company. Now, when you're large, like Vanderbilt or HCA, they can probably absorb a little bit better some sort of training and learning curve time. But yeah, I think from a data science perspective, my view is, again, if you know how to design experiments well, then you're probably going to succeed. And I think that the domain knowledge just comes with time.
I think while still in school, if you can get your hands on any claims data, be it medical, dental, pharma, vision, like just all sorts of stuff out there, right? The bigger the data set, the better. But having been in there and knowing, what exists, what fields you might have, that you can go to answer some of your questions, it's always gonna be some of the time well spent, right?
Is your data de-identified, the claims data?
So some of it is, some of it's not.
Lindsay, I think we're running short on time.
Sure, sorry.
I'll just put, we have two good questions, asked by.
Oh, from the live feed, oh, wow.
Yeah. We're waiting, so I'll just, put these two questions here and you can answer them.
Yeah, perfect.
Yeah, so the first question is, what do you think of Nashville Software School's new data science program?
I think it's great. They actually visited Axial and we gave some of our opinions about what the program should be. So I think it's great because maybe they took our opinion.
Awesome. Yeah, and the second question, how much of the skills you obtain in your PhD program transfer over to your career? And she said she asked this because she's a quantitative student who has a staff background, but
Yeah.
how much of that is transferred over?
I think a ton. I mean, I think the bottom line is even though I spent many years in diabetes drug discovery, that's really not the career value that I gain, although I know more than I care to admit about type 2 diabetes drugs. I mean, the knowledge you gain is really how to figure stuff out. The bottom line is people with this training usually know how to figure stuff out, period. And I think a lot of that is transferable. Again, it goes back to hypothesis testing. You know, I did not have that contextual knowledge in the healthcare space, but how do you get it? You Google it. I mean, I'm just being honest, right? You know, you can't underestimate that. You Google stuff, you start reading blogs, you start understanding claims data from the CMS website. You just start to get to know the space. You pay attention when, you know, there's healthcare talks, you listen to webinars. I mean, you just start to cultivate your knowledge in that area. And, you know, really that's what you do as a graduate student, right? I didn't go into graduate school knowing everything about intracellular insulin signaling. I didn't, I don't learn that in high school. I didn't even learn that as a bachelor's degree student. So you Google and you cultivate that knowledge, and it's the same with a job. You know, you're moving into a new space. I think it's almost, in my mind, a little bit preferable not to have people who've been in the space, because they don't really come with those preconceived notions of how things should be. And sometimes that's kind of nice. So, yeah, I mean, that's what you learn as in advanced training. And I'm not saying people who don't have PhDs can't do that. I think they do. I've met a lot of really talented people that don't have advanced degrees that I think do at least have that talent to be able to sort of ask appropriate questions contextually. So, you know, that skill is out there, and it's something that you have to cultivate. I think PhD programs do that in an organized way. Perfect. I think before we end, I did have one more thing. Oh, where is it? Technology. I do have a friend of mine has a job opening for a part-time data scientist, so I wanted to sort of add to Shanna's announcement. So if anyone's interested in opportunity, you can come talk to me directly. And I think that's it. Anything else, May?
Any other questions? All right. Let's
Thanks,
Dr. Morris, if you want to talk about. Thank you, everybody, for coming. Yeah, just remind you guys, please fill out the survey. You got to pay. Either you guys.
That's great. Yeah, I'll just stop this.
Yes, nice to meet you.